Greeting, Earthlings. Good afternoon. And also greetings to the Archbishop of Klapper. Lovely to see you. And I'm really glad that some people see the light with the dimensional analysis. Can you actually hear me? Yep, excellent. Fantastic. And can you see the screen? Well, what can possibly go wrong? The only thing that can go wrong is that one of the dogs has a fit or something like that and starts barking. But otherwise, I think things should be all right. So we are in week 2. How is everybody coping? Doing all right? Yeah. I know I've asked you that yesterday. Not feeling too stressed about things? Or too isolated? I hope not, Bernardo. I hope not. Oh, did you find the checklist useful? Okay, so I will try to keep that going. You probably have seen that I've set up a Moodle forum, which helps me sort of to manage all the emails and things like that. I will promise I'm not going to abuse it and bombard you with forum posts, but I think it is probably a better way, because I know that some people easily miss emails, and this way I sort of have everything in one place. I hope that's all right with you guys. By the way, you probably have seen that I posted something in the BI300 module about some quizzes. And some people have already started on them. Do you want some quizzes for BI308 as well? Okay. So because I think they are a good way for you checking where you stand, so that there are no nasty surprises. And let me put it this way. In the past, if students haven't totally pissed me off, what I have done is I use the questions from the quizzes in the exams and tests as well. So if you do the quizzes, then you shouldn't have a problem later on. So you've done the first question, Bernardo, just with dimensional analysis, and you got the answer. Well, it works, doesn't it? Shall I tell you something? When I discovered this dimensional analysis, I used for many, many years sort of the rule of threes, the first principle thing. And I was really reluctant to give it up. But then I sort of tried to practice a little bit. And I thought, wow, that's so much easier because, as you rightly say, it is sorting out the units. And very often you are, with the triangle method or with other methods, you easily miss out on a unit. And then you think, oh, flippin' heck, that doesn't look right. But with the dimensional analysis, it sort of puts the brakes on and it's quite difficult. I mean, there are occasions where it is a little bit more tricky with the dimensional analysis, but I will then show you a sort of a workaround for that as well. And hopefully there is no problem then. No, you don't need to register attendance. I don't think the Moodle would allow you to register the attendance because these drop-in sessions, it's sort of, that's not really timetabled. It's not on your official timetable. I just thought I set it up to support you folks. And so you don't need to worry about attendance. Is the sound quality reasonable? Yeah, okay. So I don't have to worry about it. And those people who want to use closed caption, hopefully the closed caption don't cause too much trouble either. So I don't need to worry too much about things. That's excellent. So we give it a few more minutes to get everybody the chance to come in. I really have to apologize. I told people apparently in the email. I told people in the email that it starts at 3 p.m., but my bad. The Teams is at 2. So, and I think I sent out a forum message saying that it is at 2. So my apologies. And by the way, people ask me where they can find the recordings. The recordings are on Moodle in the respective module. So this here would be in the BI308 Skills for Bioscientists module. On the right-hand side, under Kent Player, recorded sessions. So I hope people can see that there. Good, excellent. So they are there. I will try to upload them as quickly as I can, but the issue is there is not a direct link between Teams and Moodle for the upload. So what I have to do is I have to wait for Microsoft Streams, not Teams, Streams, to get the recording ready, then download it on my computer, change the title and upload it via Panopto to Kent Player Moodle, and with all that stuff, also try to keep my sanity. Yes, how tedious. Exactly. It's just sort of. Sorry, that was me. Right, I suggest we make a start. Are you all ready? Do you have pen and paper, a calculator? Fantastic. So this session is exactly the same one as we did yesterday. And somebody has their microphone open because I can hear myself, but that doesn't matter. Okay, so let's get started. And this session is really for people to practice, to go through these calculations, which I'm going to show you. And I will use usually dimensional analysis for these calculations in this session. I've prepared 6 questions for you. Yesterday, we managed to get them done in about 45 minutes. So hopefully we will do that this time as well. If you've got any questions, I have my headphones muted, so I won't be able to hear anything. So please questions in the chat, and I have the chat open here as well, so I can see that if people have burning questions. So here's the first question. How many millimoles of a substance are in 71.75 milliliter of a 0.77 molar solution? And as you can see here in red, there is sort of the answer if you want to try it or for yourself. I suggest I give you a couple of minutes to see how far you get with it, and then we do each question together. Are you happy with that? And as I said previously, you can do whatever method you want to use. As long as you get the right result, it's great. And you will not be marked down in any way if you use a different method. Okay, so let's get started. Let's see what we get with this particular question here, okay? Brilliant. So I would assume it has been on the screen already a little bit, so I get cracking with that. So how many millimoles? how many millimoles of a substance are in 71.75 milliliter of a 0.77 molar solution? And I want to point out, these questions are all taken from the website that I set up for you guys, and you've got the link to it in the email, but I'll put it on the forum again. There are loads and loads of questions. So you can really practice till you are whatever color you prefer to be. Okay, so we are looking for moles for an amount, and with dimensional analysis, I just simply write it as mole. And then the question is, do I have the unit mole somewhere in my givens? And the answer is yes, because this capital M stands for mole per liter. And that's what I really want you to remember. Capital M means mole per liter. Absolutely. And so we have the mole. So I write it so that the unit that I want is on top of the fraction line. So here I write it as 0.77 mole per liter. Now I see the mole is exactly in the right position. However, I've got the little problem with the liter down here. And so what I need to do is I have to multiply it with something so that the unit liter cancels out. And I've got liter here, that's in here. So I multiply it by 71.75. Now I've got a milli here, and I know that milli is 10 to the power of -3. That's the milli. And I've got liter here. Okay, so what I see now is that the liters cancel out like that, and all I've got left is really 0.77 mole times 71.75 times 10 to the -3. And I note that the only unit that is left is really my mole here. And that is exactly what I want, mole. That means I don't have to worry about any other units that are hanging around. I can now just simply stop and put that in a calculator. And I would get as an answer equals 0.05525 mole. Have I done it right? I think so, yes. And of course, there's the issue with decimal points and all these things. So what I can do is I can convert that back into millimole. And there is a very useful trick if you want to convert mole into millimole. So mole into millimole, into this milli here. You shift the decimal point 3 places to the right. 1, 2, 3. So here would be our new decimal point, and we would write 55.25 millimole. Does that make sense? And it's really important. One thing that I want to point out, we are asking about mole. So this is an amount. This here, this mole per liter, that is a concentration. A lot of second-year students struggle with that concept. One is an amount, the other one is a concentration. And I really want you to bear that in mind. There is a huge difference between them. Okay, happy with that? Let's do another question here. How many millimoles of a substance are in 1.03 gram of a substance with a molecular mass of 308.34 gram per mole? Do you want to do it yourself first? Okay, you do it. I give you a few minutes and see what you come up with, whether you get the 3.34 millimoles, whether you get that as well. And once you've got it, just give me a thumbs up. Excellent. Got it, got it. Did you actually use the dimensional analysis? Brilliant. Just for the sake of it, let's quickly do it together, this question, because there is a great learning opportunity in it, and not everybody might have got it. So what are we looking for? Well, we are again looking for the amount, moles, and let's write that down. We have mole, that is what we are looking for. Now, do we have mole anywhere? Yes, we've got mole here in the molecular mass. We have 308.34 gram per mole. So that means we have 308.34 grams is the equivalent to 1 mole, right? I can also write it the other way around. I can flip it on the head and I can say 1 mole is the equivalent to 308.34 grams, right? It's exactly the same thing. And therefore, I can write it, this unit, so that the mole is on top of the fraction line. I can write it as 1 mole divided by 308.34 grams. So what does that do? It helps me to bring the mole on top of the fraction line where I want it for the dimensional analysis. So it's on top here, and I see it's in the same position as the one that I'm looking for. Does that make sense to you guys? Sometimes I want to write it as gram per mole, but in this case, I want to write it as mole per gram. It really depends on what I want to have on top of the fraction line. Now I've got the mole in the right position. I just now need to get rid of this gram thing. And all I need to do is I need to multiply it with one of my givens so that the grams cancel out. So what I do is times 1.03 grams. That's this guy here. And I note that the grams cancel out. The only unit that's left for me is mole. So I have 1 mole times 1.03 divided by 308.34. And if you put that in a calculator, it gives you 0.00334 mole. And of course, if you're working with lots of zeros, there's always the danger that when you work with these things, you lose one. So therefore, we can convert that again into millimole. So for that, we use this move 3 places to the right trick. So we move the decimal point 1, 2, 3. Put the decimal point here. So we've got 3.34 millimole. That makes sense? Happy with that? Not a big problem. Okay, let's go for the next question. That is actually a really tricky one. We will need to make use of the principles in something that we are going to do later in the week. Should it always be in millimoles? It doesn't really bother me as long as it is correct and it has the right unit. Even if you give it in mole, if it's correct, it's correct. But of course, it has to have the right unit. So if you give me 0.000003 millimole, then I have to say, oh, something is not right here, and therefore, by default, it's wrong. Make sense? Okay, you have 784.94 millimolar solution from which you want to get 108.67 millimole. How many milliliter of this solution do you need? Do you want to try it yourself again? Okay, I'll give you a few minutes. Okay, so let's have a look. Let's do it together. Together we are strong. So what are we looking for? Let's look for liter. We can always adjust it to milliliter later on. So we are looking for the unit liter. Do we have the unit liter anywhere in our givens? And if yes, where? Absolutely right. We've got this in this capital M here, which, as I told you, is mole per liter. And this is 784.94 millimole is in 1 liter. Or again, I can write it as 1 liter is the equivalent of 784.94 millimole, or I can write this as times 10 to the minus 3, that's the millimole. Okay? So let's write it in such a way that the liter is on top of the fraction line. I have 1 liter divided by 784.94 times 10 to the minus 3 mole. So the liter is in the right position here. Now I have to work out how I can actually multiply it so that the mole down here cancel out. Okay, and I've got this here. So let's multiply it by that. It is 188.67. Let me just quickly make a little bit of space here. Times, now I've got millimole, 10 to the minus 3 mole. Okay? So what do I see? The mole cancel out. Actually, great thing, the 10 to the minus 3 cancel out. That's also quite useful. So all I have left is I have 1 liter times 108.67 divided by 784.94. The only unit that I have left is the liter. That is exactly what I want, so I don't need to do anything else apart from put that into a calculator. And I get 0.13844 liters. Or if I want to put that into milliliters, let's shift the decimal 3 points. So I would get 138.44 milliliter. Now, people have asked me, how many significant figures should you use? I will do a session on significant figures later on in the term when we talk about measurements. But I would generally, as a rule of thumb, say go for the same number of decimal points that you have in your givens here. Go for the same number of decimal points, especially then also when you have the unit milli or so, then you also calculate that in terms of milli. Does that make sense? Fantastic. Any questions so far? That was a really stupid thing that I just said, because I asked you if it makes sense. So the answer would be yes. And then I asked you any questions. The answer would be no. So whatever you put down here, it's totally nonsense for me to ask a question. So no questions. Does anyone have any questions? Let's put it this way. Clear as mud. Fantastic. Okay, now let's go to the next question here.
Oh, sugar.
And somebody has their microphone open.
Oh, whoops.
That's you, exactly.
Sorry.
Yes, no worries. Okay, so this question here, I would label that with an asterisk, because this is a question you can bet will come up in an exam. Not with these numbers, but you will have to make a solution according to something like that. And you can practice. And please do practice. because that is something that when you are doing work in the lab, this is what you do all the time. So it's really important that you get this. So a couple of minutes, try to do it yourself, and then we do it together, okay? And give me a thumbs up when you've got it. Good. And again, you can check here what the correct answer should be. Brilliant. Now, doing this question with the triangle method is a little bit more tricky because you have to have two triangles. With the dimensional analysis is just simply writing things down. Or one very big triangle, yeah. You probably can do that in a big triangle with little triangle in it. So like these Russian dolls, isn't it? Matrushka. Did I say that right? Do we have any Russian-speaking people here? Matrushka, yeah, exactly. Okay, let's do that together quickly. So, what are we looking for? Yeah, you probably. I didn't pay too much attention about the rounding, but so it could very well be an issue. But let's not worry too much about it. So what are we looking for? We are looking for the amount of grams. So let's write grams down here. And do we have grams anywhere? Yes, we do. We've got grams in here. And we've got the grams on top of the fraction line, so we don't have to do any flipping or something like that. So we have 119.49 gram per mole. Gram is in the right position so that I really want it. But now I need to get rid of mole. Do I have mole anywhere? And yes, we've got mole. Remember, capital M stands for mole per liter. So let's multiply this by 82.29. We've got a milli here times 10 to the minus 3 mole per liter. And what we see is that the mole cancel out, so that's a good thing. But I need to get rid of the liter. So I multiply it with the liters that I've got here. So 70.37 times 10 to the minus 3, that's the milli again, liter. And what I see here, liter cancels out. What is the unit that is left? Grams. Exactly. It's grams, and that is exactly what I want. So I can stop my operations now. And all I need to do is calculate 119.49 grams times 82.29 times 10 to the minus 3 times 70.37 times 10 to the minus 3. And if I put that in the calculator, oops, what happened here? I put that in the calculator and I get 0.69 something, and the unit is gram. Got it? Does that make sense to you guys? I think it is a really nice method. You probably lost one of the units somewhere when you put it in the calculator. Right. Are you ready for another question? Yeah, let's do it because today is Wednesday and there was a check if anyone is awake and listening. Thank you. Okay. Here, here we have got another question. Evil. Yeah. A substance has a sorry. A substance has a molecular mass of 564.93 gram per mole. What is the concentration of a 4.56% weight per volume solution? And I have to say, this was a question that actually decided whether a person should get a job or not. Because one of my colleagues was interviewing for a PhD position for PhD candidates. And he had, I think, 5 applicants who all on paper looked pretty good. So they did the interview. He said to me, well, they look all right. So I need to decide who I give the job to. And then he came up with a question like that and said, this is a standard question. So let's give it to all the applicants and see who can solve it. And lo and behold, it was very easy because only one person could solve it. PhD candidates. So let's see if you are better than PhD candidates. I'll give you a couple of minutes. Let's see if you can do it. Give me a thumbs up when you got it. And by the way, the hopefully right answer is here in red. A very nice question. What is weight per volume? What does this percentage actually mean? This percent weight per volume. Let's try and tease that out. So 4.56% weight per volume actually means we have 4.56 gram in 100 gram of water. And we know that 100 gram of water is the same as 100 milliliter, right? So 4.56% weight per volume means 4.56 grams in 100 milliliter. Yeah. So whenever you see something like that, X, or let's call it Y percent weight per volume, it means Y gram in 100 milliliter, or I can multiply both by factor 10, because that gives me down here 100 milliliter times 10 gives me exactly 1 liter, and up there it gives me Y grams times 10. So in this case it would be 55.6 gram in 1 liter. And that's a very easy conversion. Absolutely right, what you are saying here. So now let's do this question. What is the concentration of this solution? And we've got the molecular mass. So what are we looking for? What's the unit that we are looking for? Absolutely right. So we are looking for, let's do it properly. Let's not worry too much about the milli. Let's for the unit mole per liter in the first place. You can do it with millimolar. I prefer always using the standard units without the millis. I do that right at the end, right? So millimole per liter. And I start with looking for, do we have anywhere the unit mole? And I see I have the unit mole here, but I've got the mole in the wrong position. So I have to do the, if you like, the flipping. I have 1 mole is the equivalent to 564.83 grams. Okay? So I've got the mole in the right position. And now I need to multiply it so that the grams cancel out. Do I have grams anywhere? Yes, look, I've got my grams here. That's this one here. And I've calculated it already, so I've got it in liters. But I don't have to do it. I can write it as 4.56 gram in 100 times 10 to the minus 3 liter. And what I can see is that the grams cancel out like that. And what I've got left is mole per liter. What I have to do, I have to calculate 4.56 mole divided by 564.83 times 100 times 10 to the minus 3 liter. And that gives me 0.08073 mole per liter. And I can do the trick with the milli 3 places. So I end up with 80.73 milli. Oops, let me do this nicely. Millimole per liter. Does it make sense? So whenever, let me get a little bit of space here again. Whenever you see something like Y% weight per volume, you know that you can convert that very easily into 10 times Y gram per 1 liter. And that is really an easy step. And you can go for your PhD application now. Are there any consequences to flipping the gram per mole? I'm not entirely sure. Well, you need to flip the gram per mole into mole per gram, because otherwise people write the mole unit on top of the fraction line. Okay? Now, before we finish, here is the last question for you, and then I'll leave you in peace, okay? So give it a go. You see the correct answer or what is reasonably correct. Try to crack that question, please. I give you a couple of minutes, and once you've got it, give me a thumbs up, and then we do it together. Did you get it? Good, man. No, I've decided that I will delete all recordings because I want to piss you off. Of course, I make it available. That's the whole point of a recording. I'm not hiding it. But as I said, it might take a few minutes or hours until I upload it. It depends on Microsoft Streams. I don't want to see the word almost. I want you to be confident. But please do think. It always helps. Okay, let's do it together. What is the unit that we are looking for? Exactly. We are looking for molar or just simply mole per liter. So, do we have mole anywhere? The answer is yes, we've got mole here in our given, but we have it in such a way that we have to do the flip so that we have the mole on top of the fraction line. So we can write 1 mole is equivalent to 268.64 grams, right? That's the first thing. We've got the mole in the right position here, so that's great. Now we need to get rid of this gram here. So what are we doing? We are actually taking 29.82 grams and dissolve it in 294.43 times 10 to the minus 3, that's our milli. Okay? So here we are. Now, what happens to the grams? The gram cancel out. And what is the unit that we've got left? What's the unit that we've got left? Exactly, we've got mole per liter left. And that is exactly what we want here. And therefore we can stop. And all we need to do is we need to do the calculation. 29.82 mole divided by 268.64 times 294.43 times 10 to the minus 3, and the unit is still liter. And if we put that into a calculator, we would get 0.377 something. Oops, what was that? That's an interesting one. Sorry, pressed the wrong 0.377 mole per liter. And again, I can do the shift and I get around 377 millimolar. Are you happy with that? As my friend Alexander would say, it's simples. So what I really want you to do is practice, practice, practice. You got the link in my email. If do people want me to put it onto the BI308 forum as well, the link to my website, to the practice website? Oh, I'm so sorry. I have to sort of blow my own trumpet here. I spent about almost 1,000 hours over the last year to set up this website. So I'm really very proud of it. And please use it. I learned a lot. I learned how to use JavaScript and HTML and some CSS. So please make use of that website. Are there any burning questions left? And master of none. Any burning questions left? If that's not the case, Thank you very much for watching. Thank you for working with me. It's great, really, to see people being involved in that and engaged. And if people want, I can set up more drop-in sessions for more calculations. Would you like me to do that? I'll see what I can do. I don't want to overload you guys, but on the other hand, I want you to get things right. Rightio. Thank you very much, and I shall see you on Thursday morning. Is that right? For our next BI308 session. Take care. Bye-bye.